Now, to solve some probability problems, we should know some probability terms. So, first term is at least one of the events. Suppose two events are there, A and B, and if the terms are like that, at least one of the events A or B occur. So, at least one of the events A or B occur. So, in this case, we have to write A union B. Okay. Now, second, if it is like that, both the events A and B occur. A and B occur. Okay, so in this case, we have to write A intersection B. So if AND is there, we have to use intersection. If OR is there, we have to use union. Okay. Now third is neither A nor B occur. Neither A nor B occur. So A intersection A bar intersection B R. Neither A nor B occur. Next, fourth, event A occurs but B doesn't. Event A occurs but B doesn't. In this case, we have to write event A occurs but B doesn't. Next is exactly one of the events A or B occur. Okay, so A or B but not both. So that is exactly one of the events A or B occur. That means if A occurs, or if B occurs, B doesn't. If A occurs, then B doesn't. Okay, so this one event. Next, not more than one of the events A or B occur. Not more than one of the events. So it may be zero event or one event. So here the answer is A intersection B or A intersection B or A intersection B intersection. Okay, that means not more than one of the events A or B occur. So if the term is like that, if event A occurs, so does B. In this case, it is nothing but A is a subset of B. If it is like that, events A and B are mutually exclusive, then A intersection B is equal to phi or null. Clear? Now complementary event of A. Now for complementary event of A, we have to write A complement and sample space. So for sample space, we denote capital S to denote the sample space. Now we can solve one problem related to this particular sense. Okay. Now suppose A, B, C are three arbitrary events. Suppose A, B, C, three arbitrary events. Find expression for the events noted below in the context of A, B and C. Clear? Now, first question is only A occur. Okay, so if it is like that, if it only A occur, that means the answer should be, the expression should be A intersection B bar intersection C bar. Only A occur. Clear? Next, if the expression is both A and B but not C occur, both A and B but C not. Third, all three events occur. All three events occur. Then A intersection B intersection C. Okay. A intersection B intersection C. Now, if it is like that, at least one occur. Okay, so that means A union B union C. At least one. Okay. So in this case, we have to write A union B union C. At least two occur. So if the problem is like that, at least two occur, then A intersection B intersection C union A intersection B intersection C union A bar intersection B intersection C union A intersection B intersection C. At least 2 occur means 2 or more. So here AB occurring, AC, here BC, here ABC. So at least 2 means more than 2. Okay. Now, if that is like that, 1 and no more occur. Okay, so if the sentence is like that, 1 and no more occur, so the expression is this one. Okay. Next, 2 or no more occur. So if it is like that, 2 or no more occur, then A intersection B intersection C bar, okay, union A bar intersection B intersection C union A intersection B bar intersection C. Okay. And finally, if it is like that, none occurs. None occurs means A bar intersection B bar intersection C bar, or we can write A union B union C whole intersection. Here. Now, to solve the probability related problem, we should know some theorems. Okay. So first is probability of the impossible event is 0. That is, probability of impossible event is 0. First. Second, probability of the complementary event A bar of A is given by, so probability of complementary is nothing but 1 minus probability of A. Clear? Now, for any two events A and B, you can write this one. Probability of A bar B is equal to probability of B, okay, minus A intersection B. Similarly, we can write A intersection B bar is equal to probability of A minus probability of A intersection B. Okay. Now, if you rearrange this one, so if you rearrange this one, we can write like this way: probability of B is equal to probability of A intersection B plus probability of A intersection B. Here, similarly, we can write probability of A is equal to probability of A intersection B bar, probability of A intersection B. Okay. And finally, there is one, that is, if B is a subset of A, then we can write probability of A intersection B bar is equal to probability of A minus probability of B, and probability of B should be less than equal to probability of B. Okay. Now, to solve probability related problems, we should remember this particular probability terms. Okay, so already you have solved. So if the expression is like that, so the sentences are like that, we have to use this particular expression. Okay, you have to remember. Okay, you have to remember this one also. So you have to remember these equations also to solve the problems. Okay, now there is one very popular theorem is there, that is called De Morgan's theorem. Okay, now we have to remember this particular theorem also, that is called De Morgan's theorem. Now, what is De Morgan's theorem? Now, De Morgan's law. So in De Morgan's law, A union B complement is equal to A complement B complement, and A intersection B complement is A complement union B complement. So remember these also to solve the problems. Okay, some more formula are also there. So there is one table that is called probability table. Okay, so what is this? Suppose two events are there. Okay. Now you can draw a table for that. So if it is A, this will be the A bar. If it is B, this will be the B bar. Okay. Now so here is sum, here it is sum. Okay. Now finally this should be always 1. So this is nothing but probability of B. Here it is probability of B bar. Here the answer is probability of A, probability of A bar. Okay. So this is nothing but probability of A intersection B, probability of A bar intersection B, probability of A intersection B bar, probability of A bar intersection B bar. Okay. Now you can see here we have written that PB is equal to P A bar intersection B plus P A intersection B. So that is nothing but PB is equal to P A intersection B plus P A bar intersection B. Similarly, P B bar is equal to P A intersection B bar plus P A bar intersection B bar. Okay, addition of these two is 1. Addition of these two is 1. Similarly, PA is equal to PA intersection B plus PA intersection B bar, and PA bar is equal to PA bar intersection B plus PA bar B bar intersection B. Suppose now you can use this particular table to identify difference. Suppose you want to calculate this one, and if you know these two, so probability of A intersection B is equal to probability of B minus probability of A bar intersection B. Okay, so that means this is nothing but this minus this. Okay. Now if you know this one, now if you want to calculate this one, if you know these two, so easily you can calculate this one. That means probability of A bar intersection B bar is equal to probability of B bar minus probability of A intersection B bar. Similarly, if you want to calculate this one, and if you know this two, easily you can calculate this one. That means probability of A intersection B bar is equal to probability of A intersection B minus probability of A. Okay, I'm getting this one. So probability of A intersection B bar, that means this is equal to this should be PA minus probability of A intersection B. Here. So from this particular table also we can solve many types of problems. Okay. Now solve some few problems. Now next we will see addition theorem. Addition theorem of probability. Okay. Addition theorem of probability. Okay, addition theorem of probability. If A and B are any two events and are not disjoint, okay, if overlapping is there, then probability of A union B is nothing but probability of A plus probability of B minus probability of A intersection B. If events A and B are mutually disjoint, then formula is A union B is equal to probability of A plus probability of B. Okay, that means if two events A and B are there, and if it is overlapping is there, if they are not disjoint, then probability of A union B means probability of A, this one plus this one. So we are taking this particular portion 2 times. So that's why you have to subtract this one. Okay. But if they are disjoint, so probability of A union means probability of A plus probability of B. So this is for probability of A, probability of B. So which one is, suppose if A union B is there, so which one is applicable? So you have to first you have to understand whether it is the events are overlap or non-overlap. If it is overlap, you have to use this particular formula. If it is not overlap, you have to use this particular formula. Okay. And next is total probability. Now, the probability, okay, so what is total probability? The probability is PA1, PA2 to PAN of the mutually exclusive forms of A are known as the partial probabilities. Okay, of the mutually exclusive forms of A are known as the partial probabilities. Since PA is their sum, it may be called the total probability. That means PA is nothing but PA1 plus PA2 plus PAN. Okay, so this is called total probability. Okay, and these are nothing but partial probability. So all PA, P1, so if it is the case, say this is P1, this is P2, sorry, this is A1, this is A2, A3, A4 to AN. So probability of A is nothing but probability of A1 plus probability of A2 plus probability of A3 plus probability of A4 to probability of AN. So this is nothing but the total probability. Okay. Now, based on that, we can solve some problems. For example, suppose 5 salesmen A, B, C, D and E. For example, first problem, for 5 salesmen of A, B, C, D and E of a company are considered for a 3-number trade delegation to represent the company in an international trade conference. Construct the sample space and find the probability that A is selected. First problem is A is selected. Question, say number 2, A is not selected. And third, either A or D but not both. Either A or D but not both is selected. Okay, so the sample space means total number of total events are A, B, C, A, C, D, A, D, E. Okay, then B, C, D, B, D, E, C, D, E, A, C, E, A, B, D, A, B, E and B, C, E. Okay, now first question is what? A is selected. So how many A's are there? 1, 2, 3, 4, 5, 6. So out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, out of 10, number of favorable event 6. So the probability is 6 by 10. Second is what? A is not selected. That means 1 by 6 by 10. That is 4 by 10. And third is either A or D but not both selected. So here either A and D. So the favorable events are 1. Okay. Next 2, 3, 4, 5, 6. Okay, so 6 favorable events are there. So the answer is 6 by 10. Either A or D but not both. We should not select this one because here A and D both are there. We should not select this one also. Here both A and D are there. Okay. Similarly, we should not select this one also. Both A and D are there. So we can solve like this way. Now suppose now if 2 dice are thrown, second problem, if 2 dice are thrown, what is the probability that the sum is greater than 8, the sum is greater than 8 and neither 7 nor 11, neither 7 nor 11. So the total number of so the dice are, so we are rolling 2 dice. The favorable events for this particular problem is, so 3 6 4 6 5 6 6 6 6 5 6 4 6 3 5 5 4 5 and 5 4. Okay, so number of favorable events 1 2 3 4 5 6 7 8 9 10. So the probability is 10 by 36. So 10 is number of favorable events, 36 total number of events. Now neither 7 nor 11. So 7 means, how many 7s are there? 1 6 6 1 2 5 5 2 4 3 3 4. Okay, 11 means 5 6 6 5. So if the question is either 7, both 7 or 11, the answer will be what? 1 2 3 4 5 6 7 8. The answer will be 8 by 10, 8 by 36. Now here it is neither 7 nor 11. That means answer is 1 minus 8 by 36. So it indicates, the total value indicates neither 7 nor 11. Okay. Now solve another problem. Now two dice are now the third problem. Two dice are tossed. Find the probability of getting an even number as the first die, or a total of 8, So if event A, even number, so even number as a first die, so 2 4 6, and the remaining, so it's a first die, and for the second die the output may be any. So total number of events should be the 18. So 3 into 6, so 3 into 6, 18. 18 number is what? Favorable events. And B is what? A total of 8. So if total of 8, so already you have calculated, it is 5 by 36. Total number is event. Okay, so already, and second is what? The total is 8. The answer is 5 by 36. So the problem is an even number of as the first die, or total is 8. So probability of A plus probability of B minus A intersection B. So probability of A is what? 18 by 36. This one. Second, probability of B is what? 5 by 36. Now few cases are there. For example, 2 6 6 2 and 4 4. Both the events A and B contains this one. So you have to subtract this one. So minus 1 2 3 3 by 36, because these are the events which are common for both A and B. Okay, so if you solve this one, you can get the result. Okay, now second problem, next problem. The probability that a student passes a physics test is 2 by 3. The probability that student passes physics test is 2 by 3. And the probability that he passes both physics test and English test. Physics test and English test is equal to 14 by 45. The probability that he passes at least one test. At least one test means probability of physics union English is equal to 4 by 5. So these are the given. These are given to us. Now, what you have to solve? What is the probability that he passes the English test? So we have to solve what is the probability that he passes the English test. Here, so easily we can solve it. So you know that probability of physics union English is equal to probability of physics plus probability of English minus probability of physics intersection English. Okay. Now probability of physics is what? 2 by 3. We have to calculate probability of English. Probability of physics in intersection English is 14 by 45. Okay. And probability of physics union English is what? 4 by 5. So easily you can get the probability of English, probability of passing English. The answer is 4 by 5. Okay. Next see one concept that is called odd ratios. Odd ratios. So what is this odd ratios? Now if you write like this one, odds against an event E are x is to y. If it is like that, odd against an event E are x is to y, then probability of E will be y by x plus y. Okay. Now if it is like that, okay, so it should be the odds. Odds against an event E are x is to y. Now if odds in favor of an event E, if event E are x is to y, then probability of event E will be x by x plus y. So if it is odds against, then we have to write y by x plus y. If it is in favor, we have to write x by x plus y. Okay. Now solve one problem. An investment consultant predicts that the odds against the price of a certain stock will go up. Okay. Probability of go up, we have to write probability of go up during the next week are 2 is to 1. So since it is against, so probability of up will be what? 1 by 2 plus 1, that is 1 by 3. Next, and the odds in favor of the price remaining the same. Okay, remaining the same, we have to calculate the probability of same are 1 is to 3. So the probability of same will be what? 1 by 1 plus 3. So 1 plus 3, that is 1 by 4. Okay, so I'm repeating this one. And investment consultant predicts. So 3 events are there: up, same, and down. Okay, and all are mutually exclusive. That means, now what is the probability of up union down? Since it is mutually exclusive, so probability of up plus probability of down, that means what? 1 by 3 plus 1 by 4. Okay, now that means probability of down means what? Probability of up union down intersection. Okay, that means 1 minus probability of up union probability of down, that means 1 minus 1 by 3 plus 1 by 4, and the answer is 5 by 12. Okay, now that is the end of this particular video.